Okay, next in our geometric shapes is going to be the ellipse. So it's basically just a circle that we kind of push on one end, so we make it so it doesn't have a universal radius all the way around. Here's your definition for it. So it's a collection of points in the plane, the sum of whose distance from two fixed points, called the foci, is a constant. Okay? You have a major axis and a minor axis because unlike a circle, it has one axis longer than the other. Major always goes with A. You can think of it, major has an A in it. The minor always goes with B. And C is the distance from center to the focus. So it's going to mess us up a little bit as far as what we used to think A, B, and C are as far as the Pythagorean theorem goes. But with enough practice, we'll get it all straightened out. So this is what you guys are going to play around with in the computer lab. But here's how it's created. So you pick any 2 points, F1 and F2, they could be anywhere, and you attach a string to them. Okay, so the string's going to be 10. Okay, feet, inches, doesn't matter. If I sweep this pencil around, here's how I create the ellipse. Okay, the sum of the strings always has to be 10. You can see the sums up here. So if one's at 7, the other one needs to be about 3, 4, and 6, okay, and whatnot. So now it's going to arc out that shape right there, okay? We can see that A is always our major axis, so it's the sum of the two strings divided by 2, which should be 5. Okay, so if we have a string of 10, that means this A from the center out to here, center out to here should each be 5, or the total sum of 10. Here's why the string's got to be 2 times A, or the major axis. So if we drag this point down to there, okay, so the short distance, F2 to A, is now covered twice. So we covered it once with the string, and then it's doubling back on itself. So the thing that's missing is this little guy down here. But since that's covered twice, and that's the same distance as that, therefore your major axis is always 2 times A. Okay, it can look 2 different ways, just like the parabola. So if your major axis is on your, or running parallel to your x here, here's what your equation's going to look like. So it's kind of just like a circle, where the x squared plus y squared equals 1. So we have to divide by a major axis and a minor axis to get these things elongated. So we're going to throw centers in these guys right away. So x minus h squared plus y minus k squared. This is the major axis, so it's under the x, so it tells us it's longer in the x. Okay. Foci now are center h plus or minus c. So this little distance from there to there is a C, and this distance from there to there is a C. So we want a plus and minus to get there. The K is going to stay the same. Vertices, H plus A, so all the way out to here, that's a vertice, that's an A. All the way out to here is another vertice, there's an A. Okay, so we said the major axis was always 2A. Now, Pythagorean theorem, we've always done a squared plus b squared equals c squared, where c squared is always the longest. It's not the case here. You can clearly see a is going to be the longest thing here, so we have this little guy. B squared equals a squared minus c squared. Okay, so it is not a true a squared plus b squared equals c squared. Okay, however you got to remember that, please do. Here's why that works. All right, so we know if we drag this guy down to there, that distance from center out to there is A, or in this case, 5. So if we bring it all the way up to here, and we split these things equally, or as close as we can get up here, that means that distance from there to there on the hypotenuse is the same as this from there to there. Right? So if you take this triangle, the A is on the hypotenuse that used to lie on the axes, we said C was center to the foci, and then B is our minor axis from there up to there. So it's an A squared equals B squared plus C squared, which we just swung the C squared to the other side here in order to solve for B. Okay, so it's A squared equals B squared plus C squared, so any of those combinations you can get there. All right, here's what your ellipse looks like going in the other direction. So you still have x minus h squared plus y minus k squared. We've now flipped the b and the a. So if you see the bigger number, a is always the major. So if you see that underneath the y, this guy's going to open up on the y now. Okay, it's going to be longer on the y. There's your center. So to get to the foci, that's a distance of c. To get to the vertex, that's a distance of A. There's your little B right there. Okay, so that's the triangle you're going to make. So to find foci, we add them to Y. To find vertices, we add them to Y. Okay, again, B squared is A squared minus C squared. Here's kind of that little picture of the ellipses again. So this distance from here down to here is the same as here over to here. So if you just think about, taking the distance between those two smiley faces and putting it right there, and if you know this is A, so that swings up here, that's an A, that's your minor axis. So really you can draw your own triangles here, and A squared equals B squared plus C squared. Okay, so a little bit goofy there. All right, let's look at a couple examples. So find an equation of ellipse with the center at the origin, so we'll make this one easy. One focus at 0, 5 and a vertex at 0, -7. And then we want to get a picture of this. So I always do a rough little picture just to see which way it opens and which formula I need. Okay, center's right at the origin. Focus at 0, 5, and that's a focus. Okay, vertex down here at 0, -7. Now clearly, since the foci, or one of the focuses, is on the x-axis, or on the y-axis, sorry, this guy's got to open up and down. So we'll just get a rough picture right now, something like that. Okay. So if I know that's a vertex down at 0, -7, that means I got another vertex up here, up at 0, +7. If I got a foci at 0, 5, my other foci is at 0, -5. So if I come look at my equations, okay, I want it to open up on the y-axis. So I want the major axis on the y. So that one doesn't work for me, so I want this one. All right, it's at the origin, so I don't have an H or a K. So I'm going to start there. Put my major axis under the Y, so this is 7 squared. Come over here to X, I need to find this distance right here now. Okay, that's going to be my B value right there. I don't have that right now, so we're going to have to do a little bit of work for it. So if we pull out this little triangle in here, this little guy right here, that's the B I'm looking for. This is going center to foci, and that's 5. So this has to be an A. So this distance right here is the same as this distance right there. So that needs to be a 7. So if you draw the triangle, you don't even have to worry about memorizing this. Okay, so let's find that real quick before we head over to a part 2. So 49 equals B squared plus 25. That means B squared equals 24. That means I can go plug a 24 in here. So in part 2, we'll finish up this equation and graph this guy appropriately.